Okay, fine, fine, fine. So we'll start now. First of all, we'll revise. Within 5 minutes, we'll revise what we have seen in last lecture, and then we'll start with a new concept. So in last lecture, we have started with heat transfer. So as we discussed, heat transfer is by three mechanisms: conduction, convection, and radiation. Out of that, we will be discussing radiation. What is the basic difference between conduction, convection, and radiation? Conduction and convection needs medium, whereas radiation does not need any medium. These are some of the applications where radiation is required. Already we have discussed in last lecture, so we'll not go into detail. Just space heat exchanger where ambience is not there, right? So through vacuum, the heat transfer will be only in the form of radiation. Then in the design of boilers, design of furnaces, design of combustion chambers, solar radiations, what energy we are receiving from sun is because of radiation. For cancer treatment, we use radiations. Okay. So these are some of the basic concepts that we have seen yesterday. All surfaces, solid surfaces, liquid surfaces, and gaseous surfaces emit radiation at all temperatures except 0 Kelvin. 0 Kelvin means minus 273.15 degrees Celsius. We have seen some of the basic laws, right? Like Stephen Boltzmann's law, which states that the emissive power of a perfectly black body is directly proportional to fourth power of its absolute temperature. So already we have seen this. This is Stephen Boltzmann constant, which is 5.67 into 10 to the power minus 8. I will not go into details of all these things. Already we have seen this. We have seen the concepts of absorptivity, transmittivity, emissivity, reflectivity. We have seen what is black surface, white surface, opaque surface. Is it required to revise these things? If yes, then we'll revise and then we'll proceed, or else we'll start with the new concept. Is it required? Should we invest 5 to 10 minutes where we will go through these concepts, or should I start directly with the next concept? Hello. Okay, so directly we'll start with the next point. Now see, in last lecture we have seen laws like Planck's law, Wein's law, Stephen Boltzmann's law. Are these laws interconnected? There are two questions. First question is that, are these laws interconnected? And second question is that, if these laws are for black body, and in practice nobody is black body, so how can we apply these laws to find the energy emitted by real bodies? Let us discuss the first question. Planck's law. We have seen Planck's law. It gives monochromatic emissive power of a black surface. EB lambda is equal to 2 pi C1 upon lambda to the power 5 into bracket exponential of C2 upon lambda T minus 1, right? We have seen Wein's displacement law. Lambda m into T is equal to 0.0028. We have seen Stephen Boltzmann's law. Q is equal to epsilon sigma A T1 raised to 4 minus T2 raised to 4. Now all these laws are for black body, right? First of all, tell me, are these laws interconnected? Yes, these laws are interconnected. For example, this is Planck's law. Planck has drawn the distribution of wavelength versus monochromatic emissive power of a black body. What is there on x-axis? On x-axis, wavelength is there. What is there on y-axis? Monochromatic. Lambda means monochromatic. B means black body. Monochromatic emissive power of a black body. So he has obtained these curves, right? Now, if you talk about this peak, if you talk about this point, this is the point at which EB lambda is maximum. This is the point at which monochromatic emissive power is maximum. Now this is y-axis, this is x-axis. So what is the concept for maxima? For maxima, we say that dy by dx is equal to 0. So simply if I take derivative of Eb lambda with respect to lambda, it should be equal to 0. So this is the equation for Eb lambda. If I take derivative of this equation with respect to lambda, and if I equate it to 0, you will get Ven's law. So Ven's law can be derived starting from Planck's law. What is Ven's law? Lambda m into t is equal to 0.0028. What is lambda m? It is not maximum wavelength. It is the wavelength at which emissive power is maximum. Lambda m is the wavelength at which emissive power is maximum. And T is the absolute temperature. So is this concept clear to all of you? That Ven's law can be derived from Planck's law. Okay. Now second question is there. Stefan-Boltzmann's law can also be derived from Planck's law. Now see, simple concept is there. What will be EB? EB will be equal to integration of EB lambda d lambda. Simply it is a curve, so it is area under the curve, right? What are the limits? Limits are from 0 to infinity. EB lambda d lambda. Now, using Planck's equation, what is the value of EB lambda? The value of EB lambda. What is EB lambda? It is monochromatic emissive power of a black body. The value given by Planck is 2 pi c1 upon lambda raised to 5 into bracket e raised to c2 upon lambda t minus 1. If I substitute this value, 2 pi c1 is constant. I can take it outside the integration. This will be left inside the integration. If you work out this integration, a simple integration, you will get this. Now what are these? This is c1, this is c2. These are constants. 6 is constant, 90 is constant, 2 is constant, pi is also constant. So except t, everything present over here is a constant. That constant is called as sigma. Sigma is nothing but Stefan-Boltzmann's constant. In last lecture, we have discussed that the value of this sigma is 5.67 into 10 to the power minus 8. As we have discussed in the last lecture, it is in sequence. There is no logical reason, but to remember the value, we can remember like 5678, 5.67 into 10 to the power minus 8. So Stefan-Boltzmann's law can be derived from Ven's law. I believe that this concept is clear to you. Already we have discussed these four laws in last lecture. We have discussed Kirchhoff's law, we have discussed Ven's displacement law, we have discussed Planck's law, and we have discussed Stefan-Boltzmann's law. Now, in this lecture, we are discussing that these laws are interconnected. Stefan-Boltzmann's law can be derived from Planck's law. Ven's displacement law can be derived from Planck's law. So simple concepts are there, and I believe that these concepts are clear to you. Now, my next question is that all these laws, Planck's law is there, Stefan-Boltzmann's law is there, Ven's displacement laws is there. All these three laws, they are for black body. And in actual applications, no body is black body. All bodies are having some value of emissivity in between 0 to 1. Black body is a hypothetical concept which is having emissivity is equal to 1 or absorptivity is equal to 1. Black body is the body which will absorb all incident radiations. The word black has nothing to do with color. In last lecture we have discussed. Sun is example of black body. Ice is an example of black body. Platinum black, lamp black. There are plenty of examples of black body. If emissivity approaches to unity, if emissivity is 0.99, we will call that body as black body. Okay, anyway, now in practical applications, there will not be any black body, and all these laws of radiation are for black body. So how we will relate these laws with our day-to-day applications? So for that, we use a concept which is called as emissivity. At the top of this slide, I have written this emissivity. I believe you can see this slide. See here, emissivity. What is emissivity? It is the ratio of emissive power of a surface to emissive power of a black surface at the same temperature. I repeat, emissivity is the ratio of emissive power of a surface to emissive power of a black surface at the same temperature. As it is a ratio of similar things, it is dimensionless. As it is a ratio of similar things, there is no unit for emissivity, right? Now, If you observe these figures, you'll observe something different. See, initially, we'll see what are the values of emissivity for metals. See, for this objective exam, these questions may not be there. But if you are preparing for competitive exams like GATE, right, or a DRDO, these questions are bound to be there, right? So you can see these things in detail. Now see, brass, if you talk about these three materials, and if you talk about polished materials, so if you see the values over here, 0.09, this value is 0.04 to 0.05, this value is 0.08 to 0.14. So these values are near to 0.1. So what you can remember for objective exam, for polished metals, the value of emissivity approaches to 0.1. I repeat, for polished metals, the value of emissivity approaches or is near to 0.1. For oxidized metals, the value of emissivity is near to 0.5. For non-metals, the value of emissivity is in the range of 0.8 to 0.95. For non-metals, the value of emissivity is in the range of 0.8 to 0.95. However, these are not like, this is a general statement, this is general observation. For precise values, when you are working in an industry and if you want precise design, at that time you have to use material handbook. So these are the three things what we have observed, right? For competitive exams as well as objective exams, these three concepts are important. For polished metallic surfaces, the value of emissivity is near to 0.1. For oxidized metallic surfaces, the value of emissivity is near to 0.5. And for non-metallic surfaces, it is in the range of 0.8 to 0.95. What is emissivity? Emissivity is a concept using which we can relate any real body with black body. Now, let us see the concept of view factor, or it is also called as shape factor. Now forget about all other concepts, forget about everything about radiation. This is simple geometry. View factor is based on simple geometry. Now, what is view factor or shape factor? View factor is also called as shape factor. It is defined as the fraction of energy emitted by one surface which is intercepted by the other. For example, if this is surface 1 and if this is surface 2, if surface 1 is emitting radiation Q1, out of which Q2 is intercepted by surface 2, then what is shape factor of 1 with respect to 2? Shape factor of 1 with respect to 2, it is written by F of 1, 2. What is F12? It is shape factor of 1 with respect to 2. It is equal to Q2 upon Q1. I repeat, F12 is equal to Q2 upon Q1. Fraction of energy emitted by one which is interrupted by the other. Take a very simple example. Let's say that this surface is emitting 100 watts, out of which 40 watts is intercepted by second, right? So what will be shape factor of first with respect to second? Q2 is 40, Q1 is 100. So 40 upon 100, it will be 0.4. Is it clear to you? What is shape factor? It is defined as the fraction of energy emitted by one which is intercepted by the other. Let's say I am telling you 10 concepts, out of which you have listened only 3. So your shape factor is 0.3. So 3 divided by 10. F12 is shape factor of 1 with respect to 2. What is F12? View factor of surface 1 with respect to 2. In all reference books, this shape factor is called as view factor. In some of the books, it is also called as shape factor. So I have intentionally written both names, view factor as well as shape factor. So is this concept clear to you? I believe that this concept is clear to you. F12 is equal to Q2 upon Q1. See, this part is very simple, and even if you talk about GATE, if you open GATE paper starting from 90, in fact, even in 2019, last year, there was a question which was based on shape factor. We'll solve that question also. And that question you can solve within 1 or 2 minutes. So very simple questions are there, very simple laws are there. Just you have to memorize the laws. Rather than memorize, I will say just you have to understand the laws. The laws are very simple. So is it clear to you? What is shape factor of 1 with respect to 2? Fraction of energy emitted by 1 which is interrupted by 2. Okay. So there are some laws of the view factor. What is the first law of view factor? For plane and convex surfaces, no energy emitted by that surface will be intercepted by itself. So shape factor with respect to itself will be 0. It is also called as self view factor. It is also called as self view factor. What is self view factor or shape factor with respect to itself? F11, F22, F33. What is F11? Fraction of energy emitted by one which is intercepted by one. Now, if the surface is convex, if this is emitting, will it intercept any of this energy which is emitted by itself? No, it will not intercept. So for this convex surface, the shape factor with respect to itself will be 0. Same thing is applied to plane surface also. No energy emitted by the plane surface will be intercepted by itself. So for plane surface, the shape factor with respect to itself will be 0. Can we apply the same thing to concave surface? Now this is emitting, right? Now it is emitting. Somewhere it will be intercepted, no? So for concave surface, some energy emitted by itself will be intercepted by itself. So the shape factor with respect to itself will not be equal to 0. For concave surface, F11 will not be equal to 0. Whereas for plane and convex surface, the shape factor with respect to itself will be 0. So is the first concept clear to you? Within 1 minute, I will revise what we have seen. In today's session, we have started with shape factor or view factor. What is view factor? It is defined as fraction of energy emitted by one which is intercepted by the other. If this one surface is emitting Q1 out of which Q2 is intercepted by second surface, then Q2 upon Q1 is called as F12. F12 means shape factor of 1 with respect to 2. In short, fraction of energy emitted by 1 which is intercepted by 2. And then we have started with simple laws of shape factor. The first law is for plane and convex surfaces, shape factor with respect to itself, which is also called as self view factor, is 0. For concave surface, shape factor with respect to itself is not equal to 0. Is it clear to all of you? Any difficulty with this? Okay, so I assume that it is clear to all of you, and let us proceed towards second law. What is second law? Second law is reciprocity theorem. Let's consider that there are two areas. One is A1 and second is A2. Let's consider that there are two planes, right? First plane is having area A1 and second plane is having area A2. Now, how these areas are interrelated? By which equation these areas are linked with each other? These equations are linked with the help of reciprocity theorem, which states that A1 F12 is equal to A2 F21. What is F12? F12 is shape factor of 1 with respect to 2. What is F21? F21 is shape factor of 2 with respect to 1. So if the areas are M and N, so I can write a generalized equation AM, f of M into N is equal to AN into f of NM. I believe that it is clear to you. So we have seen two laws. First law states that for plane and convex surface, shape factor with respect to itself is 0, whereas for concave it is not equal to 0. And second gives the relation between areas. If there are two areas A1 and A2, their shape factors are linked by the equation A1 F12 is equal to A2 F21. Now, the third theorem is enclosure theorem. Consider that there are three surfaces which forms an enclosure. Let's say this is surface 1, let's say this is surface 2, and let's say this is surface 3. So what equation I can write? I can write F11 plus F12 plus F13 is equal to 1. Let us take a simple example. Let's say that this is equilateral triangle. Let's say this is emitting 100 watts. Out of this, let's say this is intercepting 50 watts. And this will also intercept then remaining 50 watts. So what will be F11? Shape factor of 1 with respect to 1. As it is flat surface, it will be 0. What will be F12? Fraction of energy emitted by 1 which is intercepted by 2. It will be 50 upon 100, which is nothing but 0.5. What will be F13? What is F13? Fraction of energy emitted by 1 which is intercepted by 3. it will be 50 upon 100. So it will be 0.5. So 0 plus 0.5 plus 0.5. See, this value worked out to be 0. This was 0.5 and this was 0.5. So 0 plus 0.5 plus 0.5, that will be equal to 1. Let us take another example. Let's say that this is not equilateral triangle, it is general triangle. Let's say this is emitting 100 watts, out of which 2 is intercepting 40 watts. So how much will be energy intercepted by 3? Obviously, it will be 60 watts. Law of conservation of energy. 100 watts if it is emitted from this, if 40 watts is intercepted by this, remaining 60 watts will be intercepted by third. Now in this case, what will be F11? Obviously F11 will be 0. We have seen the first law. What the first law says? First law says that for flat surfaces, shape factor with respect to itself will be equal to 0. So F11 is 0. What will be F12? F12 will be 0.4 because it will be 40 upon 100. So it will be 0.4. What will be F13? 60 upon 100. So it will be 0.6. So if I write 0 plus 0.4 plus 0.6, what will be the total value? The total value will be 1. Tell me honestly, is it clear to you? So instead of 3, if there are 5 surfaces, what I can write? I can write F11 plus F12 plus F13 plus F14 plus F15 is equal to 1. Why I have stopped at 5? Because 5 surfaces are there. If there are n surfaces, what general equation I can write? General equation what we can write is F11 plus F12 plus F13 up to F1n will be equal to 1. So if there are 7 surfaces, the equation will be F11 plus F12 plus F13 plus F14 plus F15 plus F16 plus F17 will be equal to 1. And need not be we should write equation starting with 1. We can write equation starting with 2 also. What equation I can write over here for 5 surfaces? F21 plus F22 plus F23 plus F24 plus F25 is equal to 1. Tell me honestly, is it clear to you? Now, the last theorem. See, these 4 simple theorems are there. What is first theorem? For flat and convex surfaces, shape factor with respect to itself is 0. For concave, it is not equal to 0. This is the first law. What is the second law? Reciprocity theorem. It links A1 with A2. A1 F12 is equal to A2 F21. Third is enclosure theorem. If n number of surfaces forms an enclosure, then the summation of shape factors is unity. If n number of surfaces forms an enclosure, then we can write F11 plus F12 plus F13 up to F1n, that summation will be equal to 1. And this is the last summation theorem. It is very simple. Let's say that this is area 1 and this is area 2. Now this area 2 is made up of, this is splitted into 3 and 4. This is splitted into 3 and 4. Let's say A1 is emitting 100 watts, out of which this A2 is the total area, is intercepting 40 watts. So what will be F12? What is F12? Fraction of energy emitted by 1, which is intercepted by 2. Right? So it will be 40 upon 100. So it will be 0.4. Right? Now, this area 2 is made up of 3 and 4. So if I draw a line over here and if I split area 2, A2 into A3 and A4, right? What will be F13? Fraction of energy emitted by 1, which is interrupted by or intercepted by 3. Let's say out of this 40 watts, 10 watts is intercepted by A3. Then how much will be intercepted by A4? It will be 30 watts. Right? So what will be F13? It will be 0.1. And what will be F14? It will be 0.3. And if you work out the summation, 0.1 plus 0.3, it will be equal to 0.4. So if 2 is made up of 3 and 4, I can write F12 is equal to F13 plus F14. I repeat, if 2 is made up of 3 and 4, I can write F12 is equal to F13 plus F14. See, if there are n surfaces, right, then there will be, how many view factors will be there for 2 surfaces? How many shape factors will be there? Let's say there are 2 surfaces, 1 and 2. So how many shape factors will be there? F11, F12, F21, F22. So there will be 4 view factors. If there are 3 surfaces, how many view factors will be there? F11, F12, F13, then F21. Simple matrix is there. So there will be 9 view factors, 3 by 3. So if there are 4 surfaces, this matrix will be of order 4 by 4. So it will be 16 view factors. So if n number of surfaces are there, how many view factors are there? N square view factors are there. In objective exams, this question can come. That for, let's say for 10 surfaces, how many view factors are do exist? So we have to write, if there are 10 surfaces, 100 view factors will be there. If there are 9 surfaces, 81 view factors will be there. Okay, we'll work out some numericals which are based on the concept of view factor. Before that, please tell me frankly, are these concepts clear to you? If these concepts are clear to you, then we'll start with the numericals. Please write in the chat box. Okay, Shoaib is saying yes. Akshay is also saying yes. Tell me very frankly and very honestly, are these concepts clear to you? See, I always believe that understanding should be of conceptual level. Okay, fine. So all are saying yes. So I assume that these concepts are clear to all of you. Okay. So within just 1 minute, I will repeat and then we'll work out numericals. Numericals are very easy. In fact, even you don't need calculator also. This kind of numericals are there. Okay. So firstly, we have seen the concept of emissivity. Already in last lecture, we have seen that just from objective perspective, I have told you the values, right? Then we have the main point of the discussion for this lecture was view factor. View factor is fraction of energy which is emitted by one, which is intercepted by the other. If this is emitting Q1, out of which this is intercepting Q2, then Q2 upon Q1 is called as F12. F12 is shape factor of 1 with respect to 2. If I write F21, F21 will be shape factor of 2 with respect to 1, means fraction of energy emitted by 2, which is intercepted by 1. Okay. There are only 4 basic laws. First law is for flat and convex surface, shape factor with respect to itself is 0, and for concave surface, it is not equal to 0. This is the first law. What is second? Reciprocity theorem. If there are two areas A1 and A2, then they are related by the equation. Their shape factors are linked by the equation. A1 F12 is equal to A2 F21. Third is enclosure theorem. If n number of surfaces forms an enclosure, then we can write F11 plus F12 up to F1n. That summation will be equal to unity. And last is summation theorem. If area A2 is made up of A3 and A4, or area A2 is split into A3 and A4, then we can write F12, that is shape factor of 1 with respect to 2, is equal to F13 plus F14. What is F12? Fraction of energy emitted by 1, which is intercepted by 2. What is F13? Fraction of energy emitted by 1, which is intercepted by 3. And what is F14? Fraction of energy emitted by 1, which is intercepted by 4. Okay, good. So all of you are saying that the concepts are clear to you. So we'll start with numericals. And this simple concept, if n surfaces are there, n square view factors will be there, right? If 7 surfaces are there, 49 view factors will be there. Now see, if you are having notebook and pen, you can write down this, or else after the lecture, I can also share the PPT with you. Okay, so we'll just discuss this concept, right? What the question is written over here. I will just read out this question for you. A sphere of radius 5 centimeter is concentric with another sphere. Find out the radius of outer sphere so that the shape factor of outer sphere with respect to inner sphere is 0.6. So there are two concentric spheres. Let's say the inner sphere is sphere number 1 and outer sphere is sphere number 2. The radius of inner sphere is given as 5 centimeter. 5 centimeter means 0.05 meter. So R1 is given to us, right? Inner sphere is 1, outer sphere is 2. We know the value of R1. What we have to find out the radius of outer sphere, means we have to calculate R2. If the shape factor of outer sphere with respect to inner sphere is 0.6, so which value is given? If this is 1, if inner sphere is 1 and outer sphere is 2, shape factor of outer sphere with respect to inner sphere means F21. I repeat, shape factor of outer sphere with respect to inner sphere means F21. Okay, next concept I want to tell you, shape factor of inner sphere with respect to outer sphere, it will be F12. It will be F12. Okay, now by observing this figure, can anyone tell me logically what will be F12? If this inner sphere is emitting radiations, right? How much will be intercepted by the outer sphere? Let's say inner sphere. Just imagine that two spheres are there, two concentric spheres, two spherical balls are there. If inner ball is emitting radiations of 100 watts, all energy emitted by inner sphere will be intercepted by outer sphere. So F12 will be equal to 1. F12, that is energy emitted by 1, which is interrupted by 2, will be equal to 1. Here it is not given that assume that F12 is equal to 1. Logically, you have to decide F12 will be 1 because all energy emitted by the inner sphere will be intercepted by the outer sphere. So F12 will be equal to 1. F21 is given to you. F21 is given as 0.6. Which value is given? Shape factor of outer sphere with respect to inner sphere. Tell me honestly, is it clear to you? If you apply reciprocity theorem, this question is from last exam, GATE 2019 for 2 marks. Now see, if you apply reciprocity theorem, A1 F12 is equal to A2 F21. You can work out the value of A1. It is 4 pi r square. You know that surface area of sphere is 4 pi r square. So A1 will be equal to 4 pi r1 square. A2 will be equal to 4 pi r2 square. You know the value of F12. F12 is 1. You know the value of F21. It is given in the numerical. It is 0.6. So simply if you substitute F12 is equal to 1, F21 is equal to 0.6, you can calculate R2. Forget about the calculations. Tell me, is the concept clear to you? So I will just check the chat box. Tell me honestly, is the concept clear to you? Okay. Okay. So can we start with the next numerical? Rather than numerical, I will say derivation. Is this numerical clear to all of you? Okay. Okay, I believe that this numerical is clear to you. If you are having pen and paper, you can write down this question. The question is find shape factor of hemispherical cavity with respect to itself. Now, even if you are not having pen and paper, we'll just discuss so that the concept will be clear to you. Now see, this one is hemispherical cavity. What we have to find? We have to find shape factor of this hemispherical cavity with respect to itself. Means we have to find F11. Now just assume that this hemispherical cavity is closed with the help of a circular disc. I think the concept of hemisphere is clear to you. Hemisphere means half sphere, right? Hemispherical cavity is there. So cavity means this will be open. So what I have done, I have simply closed this cavity with the help of a circular disc. Let's say that D is the diameter of this disc. Diameter of the disc and diameter of the hemisphere, it must be same if I want to enclose this cavity. So using circular disc number 2, I have enclosed hemispherical cavity number 1. Is it clear to all of you? What I have to find, the derivation is find the shape factor of hemispherical cavity with respect to itself. I was supposed to find F11. So what I have done, I have enclosed that hemispherical cavity with a circular disc, right? So that an enclosure is formed. If you see this figure, here an enclosure is formed. 1 and 2 forms an enclosure, right? 1 and 2 forms an enclosure. Enclosure means simply it is closed. That hemispherical cavity is closed. Okay. Now as it is closed, right, it forms an enclosure. So I can write, or we can apply enclosure theorem. What enclosure theorem says? It says that if there are 3 surfaces, we can write F11 plus F12 plus F13 is equal to 1. Now if there are 2 surfaces, what I can write? F11 plus F12 is equal to 1. What was I supposed to find? I was supposed to find F11. So what will be equal to F11? F11 will be equal to 1 minus F12. Tell me honestly, is the first step, first equation clear to all of you? What was the question? The question was to find the shape factor of hemispherical cavity with respect to itself. In last exam for heat transfer, this question was there. These two derivations were there for 4 marks each. So this was a question of 8 marks. Find the view factor of hemispherical cavity and cylindrical cavity with respect to itself. Right? This derivation was for 8 marks. So the derivation is very simple. We have to apply simple equations of shape factor. Now see, F11 plus F12 is equal to 1. So F11 will be equal to 1 minus F12. Right? Now tell me, what is the relation between A1 and A2? I can write reciprocity theorem we can apply, and we can write A1 F12 is equal to A2 F21. What we can write? A1 F12 is equal to A2 F21. Right? Now tell me, what will be A1 if R is the radius of hemisphere? Tell me, what is the surface area of a sphere? What is the surface area of a sphere? You can write the answer in chat box. What is surface area of sphere and what is surface area of a circular disc? One is the hemisphere, one is hemispherical cavity, and two is circular disc. So just tell me, what is the surface area of hemispherical cavity and what is the surface area of circular disc? Let's assume that R is the radius of the disc. Right. So for hemispherical cavity, the area is 2 pi r square. For sphere, the surface area is 4 pi r square. For hemisphere, the surface area will be half of that. So it is 2 pi r square. And A2 is what? Area of this disc is pi r square. So A1 is 2 pi r square and A2 is pi r square. I believe that this is clear to all of you. It is very simple. Surface area of a hemisphere and surface area of a circular disc. Right? Now by reciprocity theorem, what we can write? A1 F12 is equal to A2 F21. So what will be F12? A2 F21 upon A1. Right? A2 upon A1 into F21. Now what will be F21? Now this disc is insulated from the upper side. So what will be F21? F21 is what? Fraction of energy emitted by 2 which is intercepted by 1. F21 will be equal to 1. Why it will be equal to 1? Because all energy emitted by this disc, circular disc, will be intercepted by the hemispherical cavity. I repeat, all the energy emitted by the disc will be intercepted by the hemispherical cavity. I can teach you in the other manner also. If this is not clear, see, by applying enclosure theorem, also I can write F21 plus F22 is equal to 1. What I can write? F21 plus F22 is equal to 1. What will be F22? 2 number is a flat disk. For flat surface, shape factor with respect to itself is 0. So obviously F21 will be equal to 1. So I believe that this is clear to you. F21 is 1. Now what will be F12? By reciprocity theorem, A2 upon A1 into F21, out of which this F21 is 1. So F12 will be equal to A2 upon A1. Right? Now what is F11? F11, equation 1 is F11 is equal to 1 minus F12. So 1 minus F12. F12 is A2 upon A1. So it will be 1 minus A2 upon A1. What is the value of A2? Area of the disk is pi r square. And what is A1? Area of the hemisphere. It is 2 pi r square. So simply if I substitute the values pi r square and 2 pi r square, it will be 1 upon 2. 1 upon 2 is nothing but 0.5. And 1 minus 0.5 is nothing but 0.5. Right? So irrespective of the dimension of a hemispherical cavity, whatever may be the radius of hemispherical cavity, the shape factor of a hemispherical cavity with respect to itself is always 0.5. From objective perspective, you can remember this value. For hemispherical cavity, the shape factor with respect to itself is 0.5. I believe it is clear to you. If it is clear to you, we can work out the last numerical, right? The next derivation. 2-3 more numericals are there, but we will limit the concepts and we will revise the concepts so that I will get a confidence that the things are clear to you, right? Rather than covering the syllabus, the important thing is that the syllabus should be clear to you, right? Okay. Now we'll see the next derivation. We have to find the shape factor of a cylindrical cavity with respect to itself. Let's assume that this is a cylindrical cavity. D is the diameter of the cylindrical cavity and H is the height of cylindrical cavity. And we have to find the shape factor, the cylindrical cavity. I have termed as 1. I have done two-dimensional sketch. Practically, it will be a three-dimensional thing, right? Cylindrical cavity. So this is 1. I have called the cylindrical cavity. I have given the number 1 to the cylindrical cavity. Now, similar to last problem, let's assume that the cylindrical cavity is enclosed with the help of disk, which is number 2. 2 is the circular disk, right? Using which this cylindrical cavity is enclosed. Now, what equation I can write? I can write F11 plus F12 is equal to 1. So F11 will be equal to 1 minus F12. Which law is this? This is called as enclosure theorem. If two surfaces forms an enclosure, I can write F11 plus F12 is equal to 1. If there were three surfaces, I would have written F11 plus F12 plus F13 is equal to 1. If there are n surfaces, you have to go up to F1n. I believe that this is clear to you. Now in this numerical or in this derivation or for this case, what will be values of A2 and A1? Tell me, what will be value of A2? 2 is what? 2 is circular disk using which the cavity is closed. So what is the value of A2? A2 is pi by 4 d square, right? What will be value of A1? What is 1? 1 is the cylindrical cavity. 1 is the cylindrical cavity. Now we can assume a cylindrical cavity. What will be surface area of that? It will be pi dh. And what will be area of this base? Area of this base will be pi by 4 d square. Area of the base will be pi by 4 d square. So what will be total surface area of a cylindrical cavity? It will be pi dh plus pi by 4 d square. So this is the value of A1, pi dh plus pi by 4 d square. What is the value of A2? A2 is the circular disk. Its value is pi by 4 d square. Now, by reciprocity theorem, same thing is there. A1 F12 is equal to A2 F21. So F12 is equal to A2 upon A1 into F21. In this case also, F21 will be equal to 1. It is similar to last till this stage. F11 is equal to 1 minus A2 upon A1. Only values of A2 and A1 will change. In last case, what was value of A1? It was 2 pi r square and A2 was pi r square. Here, see, what is the value of A2? A2 is pi by 4 d square. And what is A1? Pi dh plus pi by 4 d square. So if you take pi by 4 as common, or let's say if you cancel pi d, you will get d by 4 upon h plus d by 4. So simply it will be d by 4. In the new denominator, it will be 4h plus d upon 4. So this 4 will get cancelled. So it will be 1 minus d upon 4h plus d. If this 4h plus d comes on this side, it will be 4h plus d minus d upon 4h plus d. Plus d minus d will get cancelled and it will be 4h upon 4h plus d. What will be its value? 4h upon 4h plus d. So tell me, is this concept clear to you? What we have calculated? We have calculated the shape factor of a cylindrical cavity with respect to itself. We have calculated the shape factor of a cylindrical cavity with respect to itself. Now see, we'll see one more numerical and then we'll revise and then we'll stop. Let's take a simple example. Now see, there are different areas. Now this figure will be given to you in GATE exam or in fact in SPPU, Pune University exam also. These figures are given to you. Now this figure is given to you. Areas are labeled, right? Now see, this dimension, this is 20 centimeter, this is 5 centimeter, this is 8 centimeter, this is 7 centimeter, right? Okay. Now this is area 2, this is area 1, this is area 3, and this total area 1 plus 3 is labeled as 4. This question was given in the university exam. This is from university exam, right? What will be A1? A1 will be equal to 20 into 5. Is it clear to you? This is area 1, 20 into 5. What will be A3? A3 is 20. This dimension is 20 and this dimension is 8. So A3 is 20 into 8. What is A2? A2 is 7 into 20. This dimension is 20 and this dimension is 7. So it is 20 into 7. What will be A4? A4 will be equal to A1 plus A3. What is 4? Area 4 is this plus this. It means A1 plus A3. Either you can use this or simply A4 is this rectangle, no? So it is a rectangle of dimension 20 by 13. So it is simply 20 into 13 centimeters square. That is nothing but value of A4. Tell me very honestly, is it clear to you? So all the areas are clear to you, right? Now, what was given in the university exam? It was given that referring to the given figure, find F12. What we were supposed to find? F12. Shape factor of 1 with respect to 2. And what was given? F24 and F23 was given. It was given that F24 is equal to 0.32 and F23 is equal to 0.28. Right? Now see, this is 2, this is 4. Right? So summation theorem I can apply now. 2 to 4, whatever energy is emitted from 2 which is intercepted by 4 will be equal to energy emitted by 2 which is intercepted by 1 plus energy emitted by 2 which is intercepted by 3, because 4 is made up of 1 and 3. I repeat, we can apply summation theorem which states that energy emitted by 2 which is intercepted by 4 will be equal to energy emitted by 2 which is intercepted by 1 plus energy emitted by 2 which is intercepted by 3. So how can I write this mathematically? I can write mathematically as F24 is equal to F21 plus F23. Tell me, is it clear to you? F24 is equal to F21 plus F23, because 4 is made up of 1 and 3. 4 is made up of 1 and 3. So I can write F24 is equal to F21 plus F23. Now out of which I know the value of F24, it was given as 0.32. I know the value of F23, it was given as 0.38. So I can calculate F21. Right? If you do the calculations, F21 comes out to be 0.04. Now, what I was supposed to find, F12. And what I have calculated, F21. Right? So how can I calculate F12? I can use reciprocity theorem, because F12 is what I want and F21 is what I am having. So simply I can write the equation A1 F12 is equal to A2 F21. I know the value of A1. A1 is how much? 20 into 5. I know the value of A2. A2 is how much? 20 into 7. So I know the values of A1 and A2. I know the value of F21. So I can calculate F12. Now see, this is not the only way by which you can solve this numerical. There may be 3-4 different ways by which you can work out. It simply depends upon you that which laws. It is like playing chess. There are n number of possible ways, right? So you can decide that which way you have to apply. But simply see, you have to apply 4 things, 4 rules. One is summation theorem, one is reciprocity theorem, one is enclosure theorem, and one is the shape factor concept. That is, shape factor of a flat surface or convex surface with respect to itself is 0, and for concave surface it is not equal to 0. So tell me, is it clear to you? If you are having any difficulties, please write in the chat box. Please write your roll numbers in the chat box. And please let me know, view factor concept, is it clear to you? Okay, so within 5 minutes we'll just revise and then we'll stop. We will revise only the view factor concept. We will not go into the other laws, right? Okay. See, today we discuss this. What we discuss? Planck's law, Wein's law, and Stefan Boltzmann's law. They are interlinked, right? From Planck's law, we can derive Wein's displacement law. From Planck's law, we can derive Stefan Boltzmann's law. We have seen the concept of emissivity, the practical values of emissivity for different surfaces. And then we have started with the concept of shape factor, which is also called as view factor. Okay. So we'll start with the concept of view factor. Within 5 minutes, we will revise and then we will stop. What is view factor? It is defined as fraction of energy emitted by one, which is interrupted by other. For example, if one surface, this is A1, area 1, is emitting energy Q1, out of which Q2 is interrupted by area 2, then what is view factor of 1 with respect to 2? It is equal to Q2 upon Q1. Q2 upon Q1. Is it clear to you? What is F12? Shape factor of 1 with respect to 2 means fraction of energy emitted by 1 which is interrupted by 2. What are the rules or what are the laws for view factor? The first law states that for flat and convex surfaces, the shape factor or view factor with respect to itself is 0. And for concave surfaces, the shape factor with respect to itself is not equal to 0. What is F11? F11, or in reference books, it is also called as FII. FII is the shape factor of I with respect to I, means fraction of energy emitted by I, which is interrupted by I. What is Fij? Fij means shape factor of I with respect to J, means fraction of energy emitted by I, which is interrupted by J. Okay. Second is reciprocity theorem. If there are two areas M and N, they are linked with the equation area of M into view factor of M with respect to N will be equal to area of N into view factor of N with respect to M. So mathematically I can write it like AM FMN is equal to AN into FNM. Or if I take a simple example, if the areas are A1 and A2, then I can write A1 F12 is equal to A2 F21. This theorem is called as reciprocity theorem, which links the view factor. The third theorem is enclosure theorem, which states that if n number of surfaces forms an enclosure, then the summation of view factors is unity. If there are three surfaces, by applying enclosure theorem, I can write F11 plus F12 plus F13 up to F1n. That summation will be equal to 1. I believe that enclosure theorem is clear to you. And last is summation theorem, that if area 2 is split into A3 and A4, then we can say that view factor of 1 with respect to 2 is equal to view factor of 1 with respect to 3 plus view factor of 1 with respect to 4. We have taken a simple example. Let's say 100 watt is emitted by this, out of which 40 is intercepted by second. What will be view factor of 1 with respect to 2? It will be 0.4. Now, out of this 40 watts, if 10 watts is intercepted by 3, obviously 30 watts will be intercepted by 4. So what will be A13? It will be 0.1. What will be F14? It will be 0.3. So 0.1 plus 0.3 will be equal to 0.4. 0.4 is equal to 0.1 plus 0.3. So simply F12 is equal to F13 plus F14. Summation. If area is split into 2, we can carry out the summation of view factors. F12 is equal to F13 plus F14. Energy emitted by 1 which is intercepted by 2 is equal to energy emitted by 1 which is intercepted by 3 plus energy emitted by 1 which is intercepted by 4. Simple concept. If n number of surfaces are there, n square view factors will be there. Then we have worked out a simple numerical. Two concentric spheres, the radius of inner sphere is known, the radius of outer sphere is to be calculated, right? And what is given? F21 is given. So simply we have written only one equation, A1 F12 is equal to A2 F21, right? Now, F12 will be equal to 1. All energy emitted by inner sphere will be intercepted by outer sphere. So F12, this value is not given in the numerical. Logically, you have to decide that if two concentric cylinders are there, or if two concentric spheres are there, all energy emitted by inner sphere, the shape factor of inner sphere with respect to outer sphere will be 1. The shape factor of inner sphere with respect to outer sphere will be 1. All energy emitted by inner sphere will be intercepted by outer sphere. So F12 is 1. So simply one equation I have written, A1 F12 is equal to A2 F21. I know the value of F21. It was given in the question itself. I know logically the value of F12 is 1. Simply I know what is A1. Area of a sphere is 4 pi r square. R is known to me. I have to calculate A2, which is nothing but 4 pi r2 square. So I can calculate R2. I believe it is clear to you. Then The derivation was there. Find the shape factor of hemispherical cavity with respect to itself. Forget about the type of cavity. If any cavity is there, just enclose that cavity. Call the cavity as 1, enclosure as 2, right? So what equation you can write? F11 plus F12 is equal to 1. So F11 will be equal to 1 minus F12. Now we have to calculate this F12. So for this we can apply reciprocity theorem. What reciprocity theorem says? A1 F12 is equal to A2 F21. So F12 will be equal to A2 upon A1 into F21. Now F21 will be equal to 1. So F12 will be equal to A2 upon A1. So what is shape factor of any cavity? Any cavity in the world with respect to itself, it is equal to 1 minus A2 upon A1. It may be a conical cavity, it may be a cylindrical cavity, it may be a hemispherical cavity. For all cavities, shape factor with respect to itself, up till this step, all steps will be same for all cavities. The final equation is 1 minus A2 upon A1. What is A2? A2 is the area of the enclosure using which this cavity is enclosed. Here in this case, it is a circular disc. Let's say R is the radius of disk. Then what will be A2? It is pi r square. And what is A1? Surface area of hemisphere is 2 pi r square. As surface area of sphere is 4 pi r square, obviously hemisphere is having half of that area of the sphere. So it will be 2 pi r square. So it is 1 minus pi r square upon 2 pi r square. Pi r square will get cancelled. 1 minus 0.5, it is 0.5. Now, cylindrical cavity with respect to itself. Let's call the cavity as 1, enclosure as 2. Just close this. Here in this case also, this is a circular disc of diameter d. Till this step everything will be same. What will be shape factor or v factor of any cavity in the world with respect to itself? It is 1 minus A2 upon A1. Now in this case, what will be A2? A2 will be pi by 4 d square. And what will be A1? It will be this surface area pi dh plus area of the base, that is pi by 4 d square. So 1 minus A2 upon A1. I have simply substituted the values of A2 and A1. A2 is pi by 4 d square. A1 is pi dh plus pi by 4 d square. This pi and 1d will get cancelled. So it will be d upon 4 plus h plus d upon 4. And it will come out to be 4h upon 4h plus d. Then here in this numerical, we have seen we were supposed to find F12. F21 was given, right? The dimensions were given. Already we have discussed this, so I will not repeat this again. I believe that the concepts are clear to you. If you are having any difficulties, you can ask me frankly, and then we will stop. If you are not having any difficulties, then you can leave, right? Okay, we'll stop here. You can leave the meeting. Shubham and Tushar, the lecture is over. You can leave.